Good morning, everyone. This is Dr. Tulsi. Welcome back to the video lecture series for probability theory stochastic process. Today, we are going to discuss about problems on multiple random variables. You see this problem, the density function of two random variables, x and y, is joint density function is given fxy of x comma y is equal to u of x, u of y, 4 into e power minus of 2x plus 2y, 2x plus 2. Find the mean value of the function e power find the mean value of e power minus x plus 1. So we know the formula of mean value. Expected value of x is equal to integral minus infinity to plus infinity. Again integral minus infinity to plus infinity, that x into dx dy. So here instead of x we have a e power minus of x plus 1. So I am replacing this x with expected value of e power minus x plus 1. So you write that formula minus infinity to plus infinity, again minus infinity to plus infinity, e power minus of x plus y into giant density function fxy of x comma y dx. Now you know this fxy of giant density function he has given. This giant density function he has not given the limits here. So that meaning is he has given the clue for the minutes. Now, what is the u of x here? You know, unit step function. So, unit step function is 1 for x greater than or equal to 0. And similarly, u of y. U of y is equal to 1 for y greater than or equal to 0. So, the limits for x here 0 to infinity. The limits are y here 0 to infinity. So, instead of minus infinity to plus infinity, we are going to replace 0 to infinity, 0 to infinity, as usual e power minus of x plus y. The giant density function formula 4 into e power minus 2 into x plus y into this u of x, u of y. Within these limits, we are going to get 1. Now, you integrate this one. You separate the terms, x terms and y terms, and then if you integrate with respect to x first, e power minus ax dx integration is e power minus ax by ax, that formula. And after separation of x terms and y terms, you do individual integration with respect to x, integration with respect to y dy. So, and then you substitute that limits, that 0 to infinity, you know, upper limit is infinity. So e power minus infinity is 0 minus e power minus 0 is 1. So in this term, we are going to get 1 term. And here also we are going to get 1 term. So finally, the answer is 4 by 9. So it is a simple problem on this giant density function, a multiple random variables, giant density function. You see another one in the formula. A giant density function of x and y, fxy of x comma y is equal to e power minus x square plus y square divided by 40 divided by 45. Find the mean value of the function x square plus y square. So for the previous problem and this problem, there is a function as given previously e power minus of x plus y. Now here there is a x square plus y square. So expected value of x formula Instead of x, we are going to be replace x square plus y square. So whatever the joint density function, we are going to be write, and then expected value of this x square plus y square. So it is a random variable. It is one random variable. It is another random variable. Whenever we are going to be write in the formula, we are going to be write in the random variable is a small x means a event. So that event, whatever the events we are going to be consider. So this small x square plus small y square are these x squares are event of a random variable x square. This y square is event of this random variable. And then this again, this fxy of x comma y he has given here. You substitute this data here. And then you rearrange these terms. You rearrange the terms of x square. There is a x square, and you can multiply this function, joint density function, with this x square plus y square. After multiplication, you will get the formula is like this. Now, and then you can arrange these terms like your standard density function, that is a Gaussian density function. Now, if you see this one, it is like a Gaussian density function. Now you see integral minus infinity to infinity, this x square e power minus x square by 40 divided by root of 40 pi. If you write the Gaussian density function, fx of x is equal to general function 1 divided by root of 2 pi sigma x square into e power minus x minus mu by 2 sigma x square into dx. So this formula is like a Gaussian density function. So we are going to be write a area under Gaussian density function is a 1. So that is going to be arranged like this. You see, from minus infinity to plus infinity, e power minus x square by 40 divided by root of 40 pi dy is equal to integral minus infinity to plus infinity e power minus x square by 40 divided by root of 40 pi into dx equal to 1. It is a Gaussian density function with a 0 mean, and the variance is sigma x square 20. So it is this value is 1. We know that you substitute here. Now, after substituting the value, remaining terms you observe here. It is equal to integral minus infinity to plus infinity. Already this function, this e power minus x square by 40 by root of 40 pi is a 1. So that is going to be with respect to, this is with respect to dy, it is with respect to dx. So it is already over. Again, you see remaining terms. And this is, you observe here, integral minus infinity to infinity. Here there is an x square. There is an x square e power minus x square by 40 root of 40 pi. And y square e power minus y square by 40 root of 40 pi into dy. So it is also a standard function variance sigma x square. So instead of x, there is in the general density function, there is no any x or x square. But here there is an x square. So we are going to write it is an x sigma x square, and there is a sigma y square. So expected value of x square plus y square is nothing but sigma x square plus sigma y square. From the given data, we know what is the sigma x square and what is the sigma y square. Sigma x square is 20, sigma y square is 20. So sigma x square plus sigma y square, we are going to get 40. It is about a problems on operation on multiple random variables in this Gaussian density function. Today we are going to stop this class. We will see in the next class. Thank you.